Well, first of all, thank to all of you for sticking around. I know I'm standing between you and the next coffee break, so I will try to make this as enjoyable as I can. So when I was preparing the slides for this talk, I wanted to find a nice analogy to help get the message across. And I was thinking about, well, how probably most of us have gone to a field trip at some point, and we probably put, well, depending on the person, more or less thought on the things that we take with us. Of course, there's nothing in the backpack that we carry that will make us love the sightseeing more or actually decide where to go. But it is important what we take with us, because if your backpack is too heavy, you're probably not going to go a long way. And if you don't have the things with you that you find that you later on need, you probably not get much further away either. So it is important what we take with us. So today I'm going to show you and talk to you about a few tools that we have been developing in a research project called Prowess that I will hope that you decide that if you want or not to take with you in your next trip as a software development trip, so to say. So apart from the excursion analogy, so to say, I also chose for the title this ExtraFunctional Mile that relates to what Richard was saying before about all those things that are not probably the core of a software development project, but do also influence how well we reach to our goal. And well, in many senses, we usually refer to those as extra requirements, as extra functional things. So for this particular talk, when I use this extra prefix in the sentences, I'm not referring to things like performance, but also the things that actually help us improve our work, improve the way we can test things, or improve the way we can implement things. It's actually anything that you can use or that will help you get from this situation we are every day struggling and trying to get to, well, as Mike was saying in the keynote, maybe we are not really sure where we want to go, but we are struggling to get there, and maybe we change our minds in the process and decide we want to go somewhere else, but we want things that will help us along that way, not get in the middle. So we want to get from something like this, from the daily struggle, to something like this, right? That's our goal. So maybe some of the things that I will show you today will help you in this transition, so to say. And as also Mike was saying in the keynote, well, there have been a number of institutions and people demonstrating through the years that it's not only about the goals and the requirements, it's the success of the development projects that we all face have a very tight number of relationships with things that we cannot really quantify. So we may think we have the feeling that if our project is going to be subjected to a lot of change, that is a risk in itself. Well, I want you not to have that impression. I want you to know that that is a fact, and we know that for a fact. We should know that for a fact. Another aspect, well, there are a number of aspects that fit in this description. It can be the number of changes that we are going to make, either because we don't know the requirements for sure and they change, or just because that's the way software is most of the times. Or it can also be related to things that we not always identify as requirements, but sometimes we do. And for this, we have a number of them. I've mentioned their performance, which is probably one of the things that worry us as a community the most. And we have the feeling that performance is important, and that projects can fail if they don't meet their performance requirements. But again, I don't want you to feel that you sort of know that. I want you to be sure that that is a fact, and we know that for a fact. There's no excuses anymore nowadays. We don't get to pretend that that can be the case. We know that it's the case. We don't either get to pretend that we don't know what the solution is. So we actually also know for a fact that the only thing that can help us lead with change or lead with non-functional requirements, such as performance requirements, or the two together, the changes that we will suffer in our software development projects that have to do with non-functional requirements, so the changes in performance requirements, the changes in reliability performance, and reliability requirements and such, that we don't know how to cope with those. The only way we can cope with those is by testing, and we should also know that for a fact. And we should also know that for a fact that the sooner we start testing, the easier it will get. Of course, we cannot guarantee the success, but we can guarantee the failure if we don't do so. So, well, you probably, well, I hope that some of you at least are right now thinking, well, tell me something I don't know, right? So yeah, we'll know we have to test, and we know we have to test as soon as possible. So yeah, what are you here to tell us about that can help us with that? Well, we can get, each and every one of us, we can have different approaches to our development projects. So each and every one of us, we are engineers, and we have our own style, so to say. So I will probably tell you, well, you should start thinking about this, and some other engineer will tell you, yeah, well, for me it works better if I do things in this way and this other way. So we have our styles. We're not going to discuss who of us is better than the others, right? But we all have something in common. And it is actually that thing that we have in common that can make a difference in our mission, so to say. And the thing that can make the difference is actually not who we are, but the gadgets that we use. And that's what this track is about, cool tools and gadgets. And the rest of the talk will also provide you with some gadgets that you, as your Erlang secret agents, will have to wisely decide how to use. So at the end of the talk, I will hope that in your own personal Erlang backpack, you will have at least some ideas of new things that you can try that will hopefully help you improve your development daily life. So before I proceed with some demos and showing you some of these tools, where all these tools have in common is that, as I mentioned earlier, they've been developed as part of this research project. It's been going on for a few months, over a year now. And it will carry on more than a year and a half. So we will hopefully still deliver more things in the months to come. But so far, it's a number of countries involved and a number of probably well-known people to you already that have been involved in the development of these tools that I will be showing you here today. So that's for the acknowledgements part. And now for the fun part. So first thing I want to show you is a very simple tool, very powerful tool also, called Smother. So what does Smother do? Well, very simple thing. Does code coverage. It's probably not really impressive. Probably most of you know some other tools that do that. We'll probably be thinking, OK, what about cover? I know cover. You probably use cover. We can also discuss how useful code coverage is as a measure. But the thing is that if you're already using cover, why would you consider using Smother instead? Well, for those of you who use cover, you know that, well, what it does is, well, you cover compile your code and you execute your tests, and then it will help you analyze which of the executable lines have been touched in that execution, right? And there's a particular definition of what an executable line of code is for cover, and I won't get into much detail about that. But Smother presents an alternative to that. And the alternative is that, well, Smother, rather than focusing on what an executable line of code is and accounting when you go through them, it focuses not, as I said, not on what you execute, but on the decisions that make you finally executing a line of code. So it implements what is called MCDC coverage. How is that different? Well, it's different because, as I said, it focuses not only on just accounting the line that you go through, but how you get to that line. So, well, there's a definition, an academic definition. I won't bother you with that. Most of the tools I will be talking about, they're papers that have been published or papers that are in the making. So I won't go into academic details, so to say. But the fact is that we will now see a simple example where we can tell the difference between what cover shows and what Smother shows instead. We can do that right now then. So is that big enough for you to see? OK, so there's a really, really simple example that I've chosen here. It's borrowed from the Francesco's and Simon Thompson books, book Erlang by example. It's, if you've read the book, there's an exercise at some point that asks you to implement a really simple database-like module with, well, you create the database server, destroy it, and they can write and delete and read, and well, that's, so this is what a simple implementation based on the use of lists could look like. Not really interesting. What I'm really interested here is in, well, you could develop that, and then you could have your tests either using eUnit, and you will probably have a number of scenarios, and each scenario will try to test some of the features that we have implemented there. And then before executing the script, what you would do with cover is that you will cover compile your module, right? You will run your tests, and running their tests could be just eUnit testing your module, or if you have a property-based testing suite, we could also run that. We will also see an example of that. But the thing is that you cover compile the module, you run the tests, and then you have something, for instance, like analyze to file, and you can export that to an HTML format. And with this model, you will do exactly a very parallel thing. You will Smother compile the module. You will also test, so run the unit test or run your properties. And then you will also analyze the file. And Smother directly outputs the file, the output as an HTML file. So we could run that on the DB module. And well, of course, I will also need to compile first all the modules. So we could run the tests. So we will run them first for cover and then for Smother. And then we have this HTML file, so one for cover and one for Smother. And the difference, well, those of you who have seen this sort of output, you're familiar with that. So it will account. So these are the executable lines for cover, and those who have not been hit, but they are in red. So the way you will work is that you will now go back to your eUnit test and add some few more tests so that you can hit those lines. But it is your own responsibility to know or to guess, and this is an easy example. So you will have to say, well, to decide to inspect the rest of the code and decide how can I hit this line, or how can I hit this other line. And as I say, it can be easy or cannot be that easy, right? So with Smother, we have a slightly different approach. So as you can see, you're not saying which lines you hit. You're saying, or Smother saying, in which way you enter that line of code that you end up executing. And when you have hit a pattern, it has this color code. So when there's something like this, that there's a number of ways you can hit that condition, it will provide a table-like summary of the ways you could enter that pattern, so that you not only can know how to hit this line, but also the different combinations of conditions or branches in that decision that you can exercise to actually enter in that path. So that's something that, well, that's where the difference between the two tools relies, right? So it's, yeah.
The red there is no coverage, or I'm not sure yet.
Yeah. So see, this is the cover.
Okay.
And then you see that there were actually no tests for the delete function. And in this case, there were not either. I mean, it was the same subset. So we can run, there was another. So the red means that the pattern has not been exercised in any way. The green means that it has been exercised in all the possible combinations. So if it's an AND or an OR, you have tried that one operand is true and the other and the combination of the two. And the yellow is that you have exercised that decision, but not in all possible combinations. And that's when it's actually useful to come and see in which way you actually went through that branch and in which other cases are not. It's actually not only a matter of have I reached that part of the code or not. It's actually useful. We find that it's useful to identifying that code, because sometimes I do actually reach that, but I'm not reaching that in all possible ways in the decision. And it actually means that part of that decision, so the decision is too complex, so I don't actually need part of that pattern or something like that. That's also the case sometimes. Yeah, I will not. Yeah, I had also here an example with proper state machine in this case, but it will have the same results. So I won't go much into that. So well, that's a very brief impression of what Smada does. There's also a tutorial on YouTube. It's a 12-minute video with a longer example that you can check. I think they are collecting the slides, and if not, I will upload them at the end of the talk so that you can click on that link instead of copying and writing down a URL. You can use the tool, okay? So it's still being improved, but it's already usable, and we also have a user survey, so if you're some kind as to try the smaller, please go and fill in the survey. It will be really, really helpful as well. And that's the address that you can point to if you want to try it. As I said, this will be online afterwards. So that's for the smaller. Next tool I wanted to talk to you about is JasonJen. What does it do is, well, it's pretty straightforward from the name. It will generate for you a number of JSON instances if you provide a JSON schema. And probably you're raising your eyebrow again. I've seen this a number of times. If you Google for that, yeah, there are a number of websites that if you set an example or if you write a JSON schema, they will provide, well, they will generate the text and you can copy and paste, or you can download a text file with that example, or even a zip file with a number of examples. But it's kind of getting in the way, right? We would like to have that embedded in our Erlang tests. So that's one of the things that you can do with JasonJen, because it's written in Erlang. But it is more powerful than other tools that you might have used before, because it's using quick check on the background to actually generate the JSON data. So well, it's efficient and it has shrinking capabilities. Well, again, we probably want to see a demo that's more exciting. So in this case, I've selected one of the, there are more examples in the JasonJen GitHub page, but this is one of the JSON schemas that you could have if you want to generate JSON objects that represent people, in this case, persons. And there are a number of properties that the people can have, and we require that at least we have a name and the exam grades, and also some other property, because we at least want to know 3 things about a person. And then we have a number of properties there which are described using, well, constraints for the length, constraints for, depending on the kind of, well, the type of the property, even things like patterns and such. So if you have something like that, you will be able to use JasonJen, and you will have to read your file. That will create, it uses Mochi Web 2, I think. Yeah, thank you. In the background, so that's a dependency. And it will create this schema, this object schema, and then you will have you will be able to turn that schema into a generator, into a quick check generator, using this module and function. And then that generator you use as any other quick check generator that you usually use. For instance, you can pick the generator, or you can sample the generator. And then there's also a validation capability in JasonJen. So provided that you have a sample value that you might have generated with the generator, or you might have got from some other source, maybe some other part of your application built that object, then you can validate a given value against that schema that you just read. So we could execute this and see a few examples. So see this person here, and we have the name, and we have the exam grades, and we also have, remember we had at least 3 properties. And it will, since we said at least 3 properties, but many other properties, it will also invent new properties, because you could actually, if you have a web service accepting that JSON, you could have a number of other fields there and this would also have to be valid against, well, it is valid according to that JSON schema. So we'll smartly produce complex and well, a variety of conditions for your JSON data that you can later on use for testing purposes, or for any other purpose that you can think of. So again, you can use JasonJen starting now. It's a little bit more work in progress than Smaller was, so be kind. And that's the URL that you can get JasonJen from. Next tool I want to mention is called LevelUSToGet. I don't think I mentioned that before, but the Prowess project is not only about testing, it's testing on the field of web services. So we pay special attention to the problems that are inherent to the development of web services. And that's what this LevelUSToGet is meant for. So to assist people that want to use property-based testing and are developing web services. And you might think, so, OK, that's OK, what's special about web services? Well, we're thinking about helping people that, well, they already have probably a WS description of a given web service, because that's the file that they use to exchange information with third parties or with clients. And they need to build models or build properties for the services that implement the functionalities described in those WSDL documents. Or else, you might have a REST API for your web service, and then you want to test against that REST API, and you have to write properties or write models that represent the behavior of that REST API. And on top of that, either of those options are in a particular domain where things change a lot. So web services are particularly victims of that continuous change. So yeah, it's difficult enough to write properties and models for web services in either flavor, but if those models, once you've written them, then they have to change, well, it's not immediately, it takes, a while to get used to it, and well, every time you change your property or change your state machine, you can make mistakes. So we want to help as much as we can in that sense with this toolkit. So what does this toolkit do? Or what will it do? Well, it will, first of all, generate your model, your test model skeletons. So I will show you now a few files to see what that means. So that, well, we want the developer to focus on exactly the behavior. No? There are a lot of things that we can automate on getting a test model out of a WS document or out of actually interacting with a REST API. So those are the first steps. And then if you want to fine-tune your model, one of the things that takes more time is actually to fine-tune your data generator. And if your data generator, if your data is described in a WSDL document, well, let's assume that you can write WSDL. So we have added to the LevelUSToGet a set of data generators that you can write in a WSDL-like flavor, so you can use the same constraints that you will directly write in a WS document. You can copy those and paste them, and it will look like a quick check or a proper generator, and it will provide efficient data generation for those kind of data structures that you usually use, as I say, in a WSDL document. And then on top of that, so once you've used the tool to create all of this, it will also lead with the changes. Okay, so the toolkit will, provided you have a WSDL version and then the updated WSDL, it will be able to update the model behind, also the properties behind. So you don't have to do all the updates manually. So in this case, I won't show you the live demo, but I will show you how the files will look like. So this is actually an example that we have taken from one of our industrial partners. And it's a real example, so to say. So they have this WSDL document that describes one of their web services, and they have a number of operations with their documents, the documentation, and their input type and the output types. So that's, well, what a regular WSDL document looks like. And then they have their XSD document, where they actually describe what the input data looks like, so, and the constraints, and what the output data has to look like, and again. So that's what they already have. So using the WSDL toolkit with these two files, the WSDL with the operations and the XSD with the data definitions, WSToolkit produces first this Erlang module that creates all the boilerplate code to actually test against that, which is, well, extracts all the functions that are present in the WSDL and creates, as I said, all the boilerplate to actually interact with that web service. So that's, like I said, that's something that you will have to write. You don't have to write it anymore. It's quite a number of work that you save. And then also, that's to communicate with the web service, but then, of course, what we also want to generate, and that WSDL toolkit generates, is the state machine that will implement that, the tests for the test model for that web service. So we have the general property that you might be familiar with if you use property-based testing already. And then there's a number of functions that we expect to have, the initial state and the commands, and those are usually generated out of the box also from the WSDL and from the XSD file with the generators taking the names of the parameters and such. And of course, what is left for the developers at the moment, we're still working on ways of extracting that, is the semantic information. So you will have to actually implement the post conditions and implement the preconditions. That's something that we still cannot do for you. But all the other things are generated for you. So we save quite an amount of work, so to say. There's a URL as in the other cases. Yeah, we still don't feel as confident as in the other two examples as to say just go ahead and use it. Of course, you can do it. First, make sure that you run the examples and you really understand what you're doing. But yeah, it will improve, keep improving. There's quite a number of things that we still want to do with this tool. Another thing, changing completely the scope. In this case, it's called readSpec. readSpec, it will, instead of generating properties or test models, as WSToolkit is meant to do, here we will take your properties or we'll take your test models and we'll turn it into something that people can read. And when we say people, we mean non-technical people or not so technical people. Okay, so the managers, as Mike was saying this morning. So, okay, human-readable versions of the test properties and models, and what do exactly mean when we say readable? Well, we actually mean Cucumber-like, and if you know about Cucumber, you already know what I'm talking about. If not, I will show you in a moment what Cucumber-like means. But Cucumber is what they call a behavior-driven development tool. It has, so your tests are specified as scenarios, and then from the scenarios, the actual tests are generated. It was originally written in Ruby, but there are many clones in many languages. In Erlang, there are 2 of them, actually. And it's a way of automating their acceptance tests, so to say. So the scenarios that the client can understand, and in a very almost human, natural language-like way. So again, some code that I want to show you to give you an idea. So this is what a description of a scenario would look like. So you will have a general description, and for each feature you have a number of, and this is the pattern that you always see, and it's kind of, I hope you can read it, but it always has the same structure. It says, given something and something and something, and those somethings are describing your input data, actually. Then when you do something, and that something is usually invoking some functionality in your system, and something, and it might, and if you have several ands, then it means a series of steps, then something else must happen. So in that something else is usually the evaluation of the functionality you're testing. So this is what you write in Cucumber, and from that, when you use Cucumber, your tests are generated. But remember that here, we want to generate this from what? Well, from something that you probably will write if you're using property-based testing, which will be this sort of thing. So as a developers, we write this, but we want to show someone else the thing that we are testing when we write things like this. That, well, we probably understand, but other people that are not so technical might not really get the picture of what kind of thing are you testing with this for all, blah, blah. So the goal is, instead of showing this to other people, you will show this, right? And for properties, it's more or less straightforward, and that part is already working. But of course, the real challenge is if you have, in this case, again, it's a borrowed example that probably many of you have heard of, is the test of the register functionalities in Erlang, register and unregistered. There's a well-known example that have been used a number of times. So if you write the quick check state machine in this case, for that example, you will define your record, you will define your initial state, and you will have your logic for the span function, and your logic for the register function, and your logic for the where is. So you will have a state machine with a number of operations, and the preconditions and the postconditions. And then this is really, I mean, you could show this module to someone, to your client, but it's really difficult to convince someone that cannot really understand this, that you are actually testing everything about your subject under test. And in this case, the kind of explanations that we are generating at the moment, so in this case, we will focus on the post condition for the register operation. Well, there's a number of things. Of course, it's a complex post condition because it depends on, so you're registering a PID with a name. It depends if that PID has already been registered or if that name has already been binded to an existing PID. So there are a number of things that you will have to check in your post condition, a number of conditions that you will implement as part of your test module. And we have to extract that, and we have to turn that into some kind of natural language description of what's going on. So we have a number of definitions, which are the parameters for the post condition, and then we have a set of requirements that are, well, the things that you will check according or in relationship to those definitions that you've made. And then you will have, well, a result, and well, that will mean that if all the above is true, then you will have a post condition true. And for all the possibilities in the post condition, we're doing that. So still, as you can see, it's kind of really verbose. So we're working in getting this into a much more compact explanation of what's going on. But this is what we will get. So it's, as I say, close to natural language description of what's going on in your test model, which is, again, something that you can try, and there's a number of examples in the GitHub page. But again, it's still work in progress, especially the part with the state machines that will come up, but slowly but steady, I hope. And then, well, 2 more tools left. The next one is called the accessibility checker, or short for audit checker. If you know what accessibility is, then I won't go into detail, but you know probably that there are a number of definitions made by the W3C consortium that describe what accessibility is concerning web pages and the things that you have to make sure that your web interface fulfills to be conformance to a certain criteria according to the accessibility criteria of the W3C, as I say. So what this tool does is to automatically check those guidelines that are automatically testable, because there are a number of things that only the human eye can test. But for all the others, we have basically translated the standard, which is a, well, very long document in natural language in this case. We have turned that into properties, into quick check / proper properties. So we have now probably one of the few implementations in programming languages of those guidelines, as I said, as properties. It's been really, well, useful to turn that into properties using property-based testing. So it's because we use property-based testing, it's been much easier to translate, because there are a number of things that you basically implement a property for each guideline. And then you collect a number of guidelines, and you implement the criteria based on that. So it's much more powerful than other checkers that you might have used. We actually, well, in this case, there's also an article coming up that compares the accessibility checker with the A checker, which is one of the most used ones. And we see how things that the A checker cannot actually find, we do find. And as in the case of the JasonJen, one of the good things for this community is that we have, well, the implementation is in Erlang. So a few side things that we have to implement in order to build the accessibility checker are already available for you. One of them is an HTML generator. So if you want to generate, or if you need to generate HTML, valid HTML or invalid HTML, then there's a module in the accessibility checker that is, it works for you. So don't go and implement your own HTML generators anymore. We have a library that does that for you at the moment. So again, going to one of the final demos that I have for you here today. So how the accessibility checker works is, well, there are a number of sources that the accessibility checker can be located. So you can check a URL, then of course you have to start inits and SSL. And then this is the module that you have to call and the function that you have to call. You will specify which level of conformance you want to test, and there are a number of levels that are implemented. The technology that you're using, we're focusing in this case in HTML, and you will provide the URL and say that you are actually testing a URL. You could also, if you have the HTML in a string, you can also directly inspect the string, or if you have the HTML in a file, and you could do that using this HTML HTML. This is the HTML generator I was talking to you about. You could, well, pick this generator and save that as a file, and then you will have a very easy way of checking what the accessibility checker actually does. So, well, the kind of output that the accessibility checker shows is that you can, of course, expect that the WC3 website, it passes a lot of the criteria. So if you go ahead and see how the accessibility library is built, you will see that there are a number of criteria, and you will see, well, which of the criteria is missing, or which of the well, of all the properties that are expected to be fulfilled are not being fulfilled. So you have, well, a good idea of why exactly you're not complying with all the rules, so to say. And if we just invoke it, it will now generate. Oh, and there's a bug in XML that we haven't actually been able to pin down. Sometimes it happens. And now we will see. So in this case, so this is the HTML file that was generated, and well, this is the conformance output. So if we scroll up, down, we will see that for that HTML that we generated, well, the criteria that failed was the 331, and the numbers are the same that are used in the W3C standard. So you can go to the standard and look for 311, and you will see the explanation there. And if you go to the library implementation, you will see, well, a function in Erlang that is actually checking what that criteria well, means. So again, you can use this, and you're mostly welcome to use it for anything that you want. I think that the most useful part is probably if you're not into accessibility, or if you're not into development of the user interface of a web service, so to say, you still can use the HTML generator for a lot of things if you're in need of such data generation. And again, the GitHub page. So the last tool I want to mention, and there will be no demo of this one because we don't have the settings here in order to allow that, is MegaLoad. In this case, we're talking about a cloud testing framework. And again, what it's supposed to be doing when it's ready is help you perform performance and load testing of your Erlang system. And again, you might have, today and tomorrow we will be hearing about testing tools. In this case, the aim is not to have the testing, a software as a service, but the whole testing as a service. Because, it's not always easy to have the in-house resources to do actual heavy performance and load testing. So MegaLoad will take care of all of that, and I will show you a few images to try and explain how we will do that. But again, as the backend idea is to use property-based testing for generating different scenarios in order to really stress your system, and then being able to shrink down from a scenario that actually causes your performance goals to be overloaded or your load to be too much for your system, in order to shrink that scenario and find the smallest scenario that still makes your performance become not acceptable. So there are a number of things that we will do with MegaLoad. So we will define tests scenarios for performance and for load, and that will mean a complex definition of what a test can do, and meaning that a given scenario might have a different number of phases. So first we create a number of, say, clients, and then we connect the clients, and then we spend some time with the clients doing operations, and then we spawn a few more clients. So a test scenario will be something complex, and the phases can be shared between, or each phase can have, we will now see what the scenario would look like, but there will be a number of constraints on how much data is going to be created and how much requests are going to be created. And those can be shared between phases or not, and the scenarios can also include smaller scenarios. So we will have a really powerful way of expressing this sort of thing, and then a backend to execute that will actually identify, OK, so if you do this, then here you find your performance problem, or here you find your load problem. And that will be done, as I said, as a service in the whole. How this links to other tools that we have seen here today? Well, the way we will write the test scenarios that we want to try is using, well, JSON, so the configuration will be JSON. That will allow us to use JasonJen to generate a lot of scenarios and then execute them and, well, have really, really powerful doubt testing in this case. So it will, as I say, will integrate with JasonJen, and the whole goal of MegaLoad will be to identify scenarios in which those performance and load test requirements are not met. But we will also have, as part of this work, like the complementary thing, because with regard to performance, we might want to see when the whole system is not performing as it's supposed to be. And in the other hand, you will also want to know when a specific functionality or a specific interaction, a specific request that you can do meets or not, or doesn't meet certain performance requirements. So we will all complementing what MegaLoad will do as system whole, so to say, or system-wide, so to say. We will also have a set of non-functional properties as part of a library that you could use, that you will be able to use to fine-grain test specific functionalities for performance. So that's coming soon, we hope. We actually tease you to stay tuned. Erlang User Conference in June, probably a good moment to hear back from us in this regard, or Erlang Workshop in September. We will see. But we will definitely be having more things to tell you. So to wrap up, there are a number of things that we've been doing in Prowess, and I hope at least you remember when you go back home that we have seen here an alternative to cover and to inspect your tests or your test efficiency, so to say. Ways of generating data. So if you have to generate a lot of JSON, remember that you saw JasonJen. If you have to generate HTML, remember that you have the accessibility checker. If you're going to work with WS documents, and remember you don't have to do all the work of generating the skeletons. We do that for you. If you at some point need to translate your properties into something that someone else can read, remember what you saw here today also. And well, and expect more things from the Prowess project. So I don't know if you will be able to hitchhike the galaxy with what you've seen today, but at least I hope that you go back, not hoping that you have been somewhere else. And I will be happy to answer any questions that you may have now. Right.
Have you thought about something like the opposite, like from the type specs, actually generating the properties, because that's what actually requires more training for developers, being able to write the properties quicker, proper.
Yeah, so the question for the camera, the question is that if we have, with the read spec tool, if we're planning on not only getting the scenarios in natural language-like form from the properties, but also getting the properties out of, for instance, the spec definitions. And the answer is, at the moment, no. So our main goal was to get something readable for non-technical people from the already technical stuff that we write. But we agree with you that it is challenging to write properties for newbies. Property-based testing is not easy from day one. And actually, the information, if you already know how to write specs, of course, there is useful information that we could at least try to generate skeletons or hints. And I don't know if that could be part of the same tool or a complementary tool, but it's something that we want to definitely look into it. Yeah, stay tuned.
Does JasonJen currently allow you to specify either independent or covariant probability distributions for types of values generated?
I don't know. So what I will ask you to do is to write, or to ask that to directly in the GitHub page, because I'm not directly involved in the development of JasonJen, so I will have to forward your questions to someone else in the project. But it's a fair question. You can check, there are a number of JSON schemas in the test folder of the GitHub project that there are a number of not really straightforward things that are supported at the moment already. I don't know if they work with probability distributions, I don't know, but yeah, by all means suggest it, because I mean, one of the goals of getting the word out soon, because some of the tools are still in alpha or beta status, is that precisely that you can give us ideas of things that we might not have thought of and improve them. So yeah, thanks.
In the last one, or second last one, the MegaLoad that we talked
Right.
about, is the tool taking care of provisioning systems in the cloud? And
Yes.
what are you using to do that?
Yeah, that's what I meant with the testing as a service. So yeah, for the camera, the question was what about MegaLoad, if it provides the resources, so the nodes and the more nodes when the load is growing, and the answer is yes. So the MegaLoad will take care of all that. So you will have you will have a user interface to specify or to help you build the JSON or generate them, and then from that's the only thing you need to provide, and of course a version of your system. But then the nodes and the spawning of more nodes or the provision of more physical machines in order to see how far your system goes, that is taken care of by MegaLoad, yes.
Any more questions? So in ReadSpec is the name, right?
Yes.
Have you thought, I know it's still in progress, have you thought about putting some sort of eDoc-like callouts from comments that then feed into the specification? Because that might save you a lot of work trying to...
Yes, we absolutely. If there are eDoc documentation in the module, that will be taken and used as part of the scenario description.
So comments can flow through about it.
Yeah, absolutely. Yes, definitely.